Hi, Scott here from the Computational Modelling Systems team at the Centre of Excellence. Today I'd like to go over a bit of an introduction to using the NCI supercomputer, which we have access to as part of the Centre of Excellence, as well as the first couple commands you're probably going to want to run once you've got access to the supercomputer. So the first thing you'll do once you start up is register for an account. If you've not already done this, you go to the NCI website at nf.nci.org.au, then accounts, then all the way at the bottom you'll need to first register as a new person, fill in all of this information, say you do agree to the terms and conditions, and submit. That'll give you an ID number. Once you've got this ID number, go to connect to an existing project and enter your ID number there, as well as whatever project that your supervisor has decided you should be part of. And leave these as they are, connect to existing system, role, as well as your surname that you entered in the last page, agree again, and submit. After a day or so, NCI will send you your new username to use on the supercomputer, as well as SMSing you a password. To connect to the supercomputer, what you'll need to do is open up a terminal and go SSH your username, in my case I'm saw562, at vayu.nci.org.au. And there we go. I've set up something called SSH keys, so I don't need to enter in my password every time, and I'll probably explain a bit more about that at a later date. So now we're in the supercomputer. You can see we've got a message of the day. So this will pop up any messages if the system has downtime, if the queues aren't working, or if hard drives aren't working. So the first thing to look at if you're having problems is to log out, log back in again, and have a look through these messages to see if there's any useful information. It also pops out what project you're being charged under. So projects are basically the accounting system at NCI. So they manage how much disk storage you have, as well as how much compute time you have available. So let's clear the screen. And the first thing we're going to look at is how much compute time you have available. So this isn't infinite, though it is pretty large. So if I run quota su and hit enter, I have the usage report for my current project. So this says in this quarter, so quarter 2 of 2013, we have about 80,000 hours of computer time, and people in my project have used about 40,000 already. Or there's about 40,000 left rather, so we've used about 30,000. There are lots of different queues here: copy queue, normal and express, both on Vayu, the supercomputer, and DC, which is the data analysis cluster. So you can also, if you think someone's overusing their quota, you can go -v under quota su. It will show you how much individual users are using. By the way, the number at the end sort of relates to the institution you were at when you first registered your account. 561 here is the University of New South Wales, 562 is University of Sydney, UTAS, and various other things. Okay, so that's computer time. To see how much storage space you have available, quota without the SU. So you hit enter, and I'm on a lot of projects, so I have a lot of things. Let's just narrow it down with a -p, W35. So this says only show the W35 project. We have to add -v. If you're not over your quota, it won't show you anything unless you add in -v. So here we have on the machine value in my home directory, I'm using 1.2 gigabytes out of 1.8 megabytes. And in the short file system, I'm using 2.3 out of 5.6 terabytes. Oh, when I say I mean everyone in the W35 project. So the quotas in the short directory are shared amongst everyone. So you can see that short has a very small amount of disk space that you can use, whereas so the home has a very small amount of disk space. Short has a very large amount of disk space. So what this means is generally you'll want to be only having your configuration settings and scripts and stuff in your home directory, but any data that you have from your models will be in the short file system. I'll just show you where that is. So that's under /short, then your project name, so W35, then your username, so in my case SAW562. So these are all my model outputs, whereas here I've just got scripts, configuration files, that sort of deal. Another thing is the home file system has backups, so if something happens to the file system, then it can be recovered. The short system doesn't have backups. Just because it's such a large file system, it's only meant for temporary storage. So if something goes kaput on the file system, which it has been known to do, and has almost happened in the past, you will lose everything. So backups are on you to do. There was also, if we go back to here, something called MDSS. This is archival storage. So this is for outputs once your simulation is done. It can be put onto MDSS. MDSS is a large file system. It's a tape robot that you can request, and it is stored at redundant locations. So if something happens to the file system, then your data can be recovered. However, if you do something like remove a file, there aren't like time backups, so you can't go back in the past and recover it. So you do have to be careful there. MDSS is another subject that we can probably look at in a later video. Now the last thing is runs that you're going to put on the queue. So if we go init nqstat. nqstat shows you things that are currently running on the supercomputer. So this is under just your own project. qstat on its own, without the n, will show you everything that's running on the project. So this has a job identification number, a job name, a user who's running the job, as well as the resources it's currently consuming, the status of the job, so this job is on hold, so it's not consuming any resources. If we go up to the top, we can see that some are running and have been running for 15 minutes or 5 minutes, as well as the queue they're in. Normal is the queue you're most likely wanting to use. It's sort of the bog standard queue. There's also Express. Express is for small jobs, so if you're doing debugging or if you're doing a compilation, you can use Express. There's smaller limits. It costs more, but it's generally quicker to get running. To submit a job, if you just got, say, foo.shell, let's make a quick file, and echo hello. You run qsub for qsubmit, and then the name of your file. So now there's a job running, which we can see here. My job is queued. It's the script foo.shell, and it's got the default runtime, which is an awful long time, and the default memory usage and number of CPUs. One thing you can do is add in flags here. So if I added hash pbs-l, this will change the resources. I want to change the wall time to 2 minutes. Now I can delete the previous job with qdel for qdelete, and then put in that number, and I'll stop that from the queue. So now if we go to nqstat, it won't be there. qsub foo.sh again, nqstat, and now we can see that the time is, rather than the default of 47 hours, it's going to run for just for 2 minutes. The less resources you're asking for, the more likely that the queue system is going to put you at the head of the queue instead of having to wait until everything before you is done. So it tries to just fill in any gaps where it can. Lastly, there's a few other things you can add here. So you can add vmem is the amount of memory you have available for your job. So say 1 GB. And if you've got a parallel job, you can add n CPUs for number of CPUs. Say I wanted 4 CPUs to run my command. And there we have it. So that will request 4 CPUs, 1 GB of memory for the whole thing. So each CPU would have about 250 megabytes, and a wall time of 2 minutes. So that's been a basic introduction to using NCI. You can see my run's finished there, nqstat, so it's no longer there, and we can look at its output, which will be your job name plus a .o and the job number. And there we have it. We said hello. Our resources used was not terribly much, just to say hello. Okay, thanks for watching, and I'll see you next time.